Hi, Assalamualaikum. My name is NURSHAZLEEN bin NORASHID. My student ID is 2021-207-088. Today, I want to present about my mini project, which is soil stabilization. Firstly, we start with our introduction. The objective of this experiment is to stabilize the soil using additive soil to make the soil get strong. Next, to determine the particle density and also to determine the passage limit and liquid limit. For this experiment, I used three types of experiment. Firstly, of particle density, second, liquid limit, and lastly, passage limit. The background of study for this experiment to complete involved to figure out the characteristic of soil after it has been treated with a substance containing palm oil boiler ash, which is Poba. Range of modified soil were prepared by adding Poba contains 3%, 5%, and 7% throughout the wet mixing process. The addition of 7% Poba in soil show the best characteristic is in the tested consistency of its physical properties. With our methodology. Now, we start with our first experiment, which is particle density. The apparatus that we use is density bottle with stopper having capillary hole at its center. Next, wash bottle. Third, the air distilled water. For either balance, and lastly, vacuum sets. Now, we start our procedure for particle density. Firstly, clean and dry the density bottle and stopper properly. Next, wet the dry bottle with stopper and record the mass for M1. Then, wet the Poba using 3%, 5% and 7% of soil for next experiment. Then, for 0% of Poba, take 10 or 20 grams of oven dry soil sample cooled in desiccator. Put it carefully into the density bottle. Wet the bottle with soil and stopper. Record the mass for M2. Next, pour about 10 ml DA distilled water in the bottle to soak the soil. Leave it for a period of 2 to 10 hours. Pour some more distilled water to make the bottle half full. Remove the extra air by applying particle vacuum. Pour some more distilled water into the bottle and fill it completely without any attract bubble. Put the stopper on. Keep the bottle on the stand in constant temperature water bath for 1 hour. Take out the bottle from water bath, wipe it clean and dry from outside. If the capillary of the stopper is not full, fill it with drop of distilled water again. Again, make sure the bottle and stopper are clean dry. With the bottle filled with water and soil samples with stopper. Record the mass. Empty the bottle and clean it properly. Fill the bottle entirely with distilled water. Make sure there are no attract air bubbles, or otherwise, the partial vacuum has been used. Put the stopper and wipe the bottle dry from outside. Now, wait and record the mass for M4. Again, empty the bottle and dry it up properly. Then, repeat the same experiment to change with 3%, 5% and 7% of Poba. The another procedure is for attribute limit test. The apparatus that I use for this experiment is Casagrande liquid limit device, grooving tool, spatula and palette knives, monster cans, wash bottle containing distilled water, weighing balance, glass plate, and drying oven. The procedure is weigh the 3%, 5% and 7% Poba using weighing balance. Next, label and weight 3 empty moisture cans. Then, for 0% of Poba, take 200 grams of the soil and place it onto glass plate. Thoroughly mix the soil with a small amount of distilled water until it appears as a smooth uniform paste. Cover the mixture with cellophane to prevent moisture from escaping. Then label it with 3 empty moisture cans. Then adjust the liquid limit apparatus by checking the head of drop of the cup. The point on the cup that comes in contact with the base should rise to a head of 10 mm. The plug on the end of the grooving tool is 10 until 13 mm high and should be used as a gauge. Practice using the cup and determine the correct rate to rotate the crank so the cup drops approximately 2 times per second. Place a portion of the previously mixed soil into the cup of the liquid limit apparatus at the point where the cup rests into the base. Squish the soil down to eliminate air pockets and spread it into the cup of the depth of about 10 mm its deepest point. The soil pad should form an approximately horizontal surface. And use the grooving tool carefully to cut a clean straight groove down the center of the cup. The tool should remain perpendicular to the surface of the cut as groove is being made. Use extreme care to prevent sliding the soil relative of the surface of the cup. Make sure that the base of the apparatus below the cup and the underside of the cup is clean of soil. Turn the crank of the apparatus at a rate of approximately 2 drops per second and count the number of drops it takes to make 2 halves of the soil pad come into contact at the bottom of the groove along a distance of 30 mm. If the number of drops exceeds 50, then go directly to step 8 and do not record the number of drops. Otherwise, record the number of drops on the data sheet. Take a sample using the spatula from each of the soil pad. The sample should include the soils of both sides where the groove come into contact. Place the soil to the moisture can. Immediately with the moisture can contact to the soil, record its mass and place the can into the oven. Leave the moisture can in the oven for at least 60 hours. Place the soil remaining into the cup onto the glass plate. Clean and dry the cup on the apparatus and the grooving tool. Remix the entire soil specimen on glass plate. Add a small amount of distilled water to increase the water content so that the number of drops required to close the groove decrease. Next, repeat steps 6, 7, 8, 8 for at least 2 additional trial producing successively lower numbers of drops to close the groove. One of the trials should be for a closure requiring 30 to 40 drops, one for closure between 20 and 29 drops, and one trial for a closure between 10 to 19 drops. Determine the water content for each trial by using the same method using the first laboratory. Remember to use the same balance for all weighing. Lastly, repeat this step 2 until step 11 to mix the soil with 3%, 5% and 7% for using Poba. Experiment is plastic limit. The procedure is with 3 empty moisture cans and record the respective weight and moisture cans number on the data sheet with the Poba for 3%, 5% and 7% for soil. Then, take the remaining 20 grams of the original soil sample and add distilled water until the soil is at a consistency where it can be rolled without sticking to the hand. Next, form the soil into an ellipsoidal mass. Roll the mass between the palm of the fingers and the glass plate. Use sufficient pressure to roll of the mass into a tray of uniform diameter by using about 90 strokes per minute. The tray should be deformed so that its diameter reaches 3.2 mm is taking no more than 2 minutes. When the diameter of the tray reaches the correct diameter, break the tray into several pieces. Knead and reform the pieces into ellipsoidal masses and re-roll them. Continue this alternate rolling, gathering together, kneading and re-rolling until the tray crumbles under the pressure required for rolling and can no longer be rolled into a 3 mm diameter thread. Then gather the portions of the scrambled thread together and place the soil into a moisture can, then cover it. If the can does not contain at least 6 grams of soil, add salt to the can from the next trial. Immediately with the moisture can containing the soil, record its mass, remove the lid and place the can into the oven. Leave the moisture can in the oven for at least 60 hours. Repeat step 3 until 6 for use mix of soil and Poba. Determine the water content from each trial by using the same method used in the first laboratory. Remember to use the same balance for all weighing. Next, the data has been shown in this slide. Now we can get the percentage of Poba used for 0%, 3%, 5%, and 7%. And also we can get the result for plastic limit and particle density. The discussion for this test is for particle density. Based on the result of this experiment, I will get the mass of dry soil, mass of water use, and mass of water to free density water. The student used different percentage of Poba to find the different value of particle density, specific gravity, and corrected specific gravity. I'll also do the experiment with 4 different percentage to find the performance of soil. Start with 0%, 3%, and 5%, and end with 7%. For temperature that I used during lab session is 21 degree. So for the result, I got the particle density for each percentage is 2.3, 2.42, 2.45, and 2.49. Next, for specific gravity that I got for the lab is 2.3, 2.42, 2.45, and 2.49. Lastly, corrected specific gravity that I changed for 27 Celsius. Even I changed the corrected or specific gravity, the value is the same as specific gravity and particle density of soil. It happened because of the theory from formula. From the experiment, there are some errors which is when weighing the apparatus like bottle and stopper or the mass of soil. So, to avoid this problem happen again, I will do 3 times weighing the apparatus to get the average of value. The discussion for liquid limit and plastic limit is based on the result of this experiment. Students can determine the liquid limit and plastic limit of a sample of soil. From the percentage of Poba, it can affect the value of liquid limit and plastic limit. Also, it can affect the dry soil. For the experiment, they use 3%, 5% and 7% to replace the quality of soil. For 0%, the water content that we get for 0% is 42.66%, 44.44% and 45.45%. For number of drop, I got 38, 22 and 10. Then the value of liquid limit is 44% and plasticity index is 80%. Next, for 10%, I got the water content is 33.33%, 50% and 75%. For number of drops is 39, 22 and 14. The value of liquid limit is 53% and for the plasticity index is 24%. Next point is for 5%. The value of water content is 30%, 3.3% and 50%. For number of drops is 40, 22 and 13. Moreover, the liquid limit value is 38% and plasticity index is 12%. Lastly, for 7%, I got the value for water content is 3.33%, 50% and 75%. And the number of drops is 36, 21 and 13. Then the liquid limit is 53% and the plasticity index is 22%. For the next topic is plastic limit. The water content that I get start from 0% is 28.57%, 3% and 25%. For the next topic is plastic limit. The water content that I get start from 0% is 28.57%, 3% is 25%, 5% is 16.67% and for 7% is 16.67%. Logically, the sample that has low number of drops should has the highest moisture content. A sample that has higher number of drops should has the lowest moisture content. This is because if the soil has higher water content, it takes short time to make the distance between soil become closer, which needs low number of drops. In the conclusion of this experiment, Poba can replace the chemical soil to provide the construction. It also can save the cost because it no need to buy the expensive chemical to make the soil getting strong. Poba also have the physical properties of the test Poba modified to show good consistency with certain compositions of Poba were incorporated, especially in the sample with the addition of 3%, 5% and 7% Poba weight. Then, plasticity index show the decrement with 3% and 5% of added Poba and increment pattern with 7% added Poba, which reflects the enhancement of the temperature susceptibility resistance of modified of soil. Lastly, we need to focus on the different values of mass of soil solid and mass of pore water so we can get the moisture content for this experiment. That's all from me. Thank you.